So this question is a diagram question. Anytime I have a graph, I like to look at the title of the graph. In this case, phase diagram for aluminosilicate and polymorphs. Never get stuck on pronunciation. They don't mean anything. So I can even say phase diagram for AP. I look at the axes. So my x-axis is the temperature, right? So this is the T-axis. And my y-axis is the pressure. So this is the P-axis. Always look at the information underneath the graph to see if there's any other details provided. So it says during mineral formation, the same chemical compound can become different minerals depending on the temperature and pressure at the time of formation. Right, so I'm assuming these are the different minerals you can be. So if you're in the region here, you're kyanite, right? So basically if you're between really 0 degrees all the way to 800 degrees, but you have to be above this 0.2 in the pressure. You can be sillimanite if you're in this area. You can be andalusite if you're in this area. So a phase diagram is a graph that shows the conditions that are needed to form each mineral. The graph above is a portion of the phase diagram for aluminosilicates with the temperature T in degrees Celsius on the horizontal axis and the pressure P in gigapascals on the vertical axis. Okay, so not really anything important there that we couldn't tell just by looking at the graph. The question here provides this equation here, which we don't know what it stands for quite yet, and then goes on to say an equation of the boundary line between the andalusite and sillimanite regions. Okay, so let's clean this up so we're focusing our attention on exactly what this question is asking us to pay attention to. So this equation represents this boundary line here that I'm going to highlight in red. What is the meaning of the T-intercept of this line? Well, where is the T-intercept? The T-intercept is right here, right? In fact, as pointed out, it's this ordered pair, 760, 0, where 760 is the temperature, because that's the X value, and 0 is the pressure, that's the P value, or the Y value of that ordered pair. All right, so let's look at the answer choices. Choice A says it is the maximum temperature at which sillimanite can form. Well, sillimanite is in this area. Sillimanite goes out beyond 760 degrees, right? If I'm at 800 degrees even, if I'm at 799, right before that vertical line for 800, I'm still sillimanite. So A is not accurate. 760 is not the maximum temperature. Choice B, it is the temperature at which both andalusite and sillimanite can form when there is no pressure applied. Well, the no pressure applied means P equals 0, which is exactly what we have here. So I like that part. And then it is the temperature at which both can form. Well, both can form, that makes sense for if you're on this line, right? So that 760, 0 is technically on the line represented by this equation. So yeah, I would assume if you're on that line, you could be either or. So I like choice B. Let's circle that, but let's continue to look at the other ones as well. Choice C, it is the increase in the number of degrees Celsius needed to remain on the boundary between andalusite and sillimanite if the pressure is reduced by 1. So I don't like that at all. First of all, where is the pressure reduction? Like, how do we know that at all? I don't think that's accurate. And then increase in the number of degrees. There's nothing about the single point 760, 0 that tells us anything about an increase in the number of degrees or a reduction in the pressure. Choice D, it is the decrease in the number of gigapascals. So it looks like D is just a reverse of C in some ways. So I don't like that either, right? B is a much better answer than both C and D. So I'm going to go with B for this question.